Hello, I am about to explain how to use Entroper from the website entropment.com. So this website you have here. Probably you have a source code or you have compiled version with using YoYo and build, or you probably took the executable from our website. So I'm gonna show how it works. Let's roll. We are starting the program. We are interested in the first thing. You need to create a simulator for hardware security model. So you need a key bundle. We create a key bundle, and if you copy here, if you click here, it is copied. It will lead us here. So you can use it in Explorer, and this is your name to set key. This is some random number of some random keys when they were created. So you can put your name here, and you can change the name of the key bundle. It's just the name of the file. Then you copy this. Let's say it will be called John. John is a very good name. So you name it however you like. Like John name key bundle. Inside you can change the name from no name to your name. Obviously, this function would be used in the hardware security module, so you will not have this kind of access to this. And after all, you copy this here, or whatever you like to have fast access, and this is created. Those are those numbers we have inside. So we don't worry about this any longer. And the same bundle must have sender and the receiver. Those numbers are gonna change, and they're gonna change very fast. So let's say we want to send a message. We go to fully functional encryption. We are loading our key bundle. So this is our key bundle. Now we are copying the message. We're converting it. And here this is converted to something like buffer. So we have zeros and ones. I explained it in the film about the test loops. So you can send some information just by using some Solomon instead of this. Let's say we reset it. What is important, I need to copy and paste it again, is to set redundancy, like 5 is good. Usually you will not use this. Usually you will use a buffer and Solomon, so you don't care about this function. Now it is ready to entrop, so it is a raw buffer. A raw buffer consists 480 bits for every block that are sent, and this means there are like 18 or 19 floats, 64. Let's say 18, because some of them are just integers, so they can be compressed quite a bit. Okay, and here we start the entroping. This is the number of fakes we are creating for every block, so they're growing rapidly. And the message is about to be prepared. The result of this message will be a JSON. However, in any normal utility, you will not about to send JSON, you will just send numbers. But I keep it open so anybody can modify the function. Okay, cipher file saved. As we see, nothing is going on here. It's ready. Our line is gone. We are going back to our export, and here we have our cipher. It is not a cipher, but using this terminology to be easily to understand. So this is our cipher, and this is what we are sending. Have fun to trying to attack it. Like with any analytical function, it will be a lot of fun. I already know the results. Okay, and let's say we are resetting it. Now we are the receiver. A receiver going to decrypt. He is using a key because he has the same key as we had. Because after encrypting, we have a new key. This is our previous key, history. And this is a current key, so modified key. Very modified, like those numbers have nothing to do with the previous. Still one block. And we have made a lot of blocks. Okay, we are about to load our cipher. Here we have a cipher. And the only place you're gonna see the result, we have autosave. This is important if you want to see the result other way than in virtual machine output. So we are transcending, and we're gonna see what we're gonna get. This is how many blocks are left to be done. Decryption is a bit faster because it is not pushing any fake blocks and it's not testing. He found one candidate, decrypted it. We have this in output. We can see this in output. Readable message. There are also strings that were unsorted, so they didn't fit anywhere. You can find some off bits here and there in the message, but it is readable. And the unsorted string are the start, the end, so this is the filler to fill the space for exactly 480 bits in the block, so there are some random data, and this is one lost string that we didn't find place for it, like this too. Because we have 5 copies of every chunk of the text, the message is readable. If you go back to the simulator, now you have another key. This is the copy for the receiver, and this is our original from the sender. As you see, they are now exactly same. There you are. So now they are exactly same, but this is the history key. As you see, they created in a bit different time. So, and as we see, our current key, so used for the next message, is also exactly the same. So our key bundles were modified completely, and here we have the message itself. This is our message that we have received. So this is exact same thing you have here in the output. And this consists all what it does. If you want to break somewhere and use your own buffer, you just need to put it here. So you need to change this file, not file, this variable. So this variable is one holding the raw bits, and then you go. That's all. Here it is the starting function, so the first block, it is preparing and so on. The encoding the string to the buffer is completely separate function, and it is performed before you even can start the let's call it encryption. So you can use Solomon for any buffer, and you can just put this buffer here instead, interrupting the function, and you can run with whatever data you like. Thank you.